Okay, here we have 6-7, coordinate proof with quadrilaterals. So main idea, vocab, new vocab this time around. Now these are all pretty much just plotting things and stuff like that, so it's, I think, nothing but examples. So example 1, position and label a square with sides a units long on the coordinate plane. So here's your lovely axes. Now if you get to place this wherever you want, the best place to start is down here in the origin. So there's one corner. Now if this is a square, I'm going to have 3 other points, so that side, that side, that side, that side. If each side is a units long, this point here is at a comma 0, because I want a units that way. This point is at 0 comma a. This point is at a comma a. And there's a square with a length sides on the coordinate plane. Okay, example 2, name the missing coordinates for the parallelogram. So I need to fill in point D here. So here, so if I look down here, A is at 0, 0, B is at B0, which means that this distance is B. Up here I have B plus C, and it's A units up. So point D has to be at A units up, because a parallelogram, that side has to be flat. Now to figure out what this one here is, if this unit's B, and this unit is B plus C, that means the shift here has to be C units, because to go from here to here, I went B, but then I need a little bit more, and that little bit more is because I had to start over. So D is at C comma A. All right, example 3, name the missing coordinates for the isosceles trapezoid. So I am missing the x value there, and I'm missing the y value there. Now that y value is easy enough to figure out. That's C, because it's the same y value as there. Now this x value is going to be a little bit trickier. So this distance here, if that points at AC, this distance down here is A. If C is at A plus B, that means that the distance there is B. If this is an isosceles trapezoid, if that's A, so is that. Which means that this distance here is A plus B plus A, or 2A plus B. Example 4, prove that these are parallel. Now the easiest way to do this is to write these two lines in slope-intercept form. So if I have 14x minus 6y equals 0, and I have 7x minus 3y equals 56, bring the x over, so negative 6y equals negative 14x. So divide 14 over 6 is 7/3 x. So here I'm going to bring the 7x, so negative 3y equals negative 7x plus 56. Divide everything by negative 3, 7/3 x minus whatever 56 over 3 is. I don't know. It doesn't actually matter, because all I'm looking at are those values. Because if those slopes are the same, those lines are parallel, which they are, so it is. Alrighty, and the last example. Write a coordinate proof to prove that the crossbars of a rhombus-shaped window are perpendicular. So if these are perpendicular, they meet at a right angle. If they meet at a right angle, the products of the slopes are -1, or one is horizontal and one is vertical. So I just need to find the slopes. So the slope for AC is y minus, so y2 minus y1 over x2 minus x1, 2a minus 0, so that is 0 over 2a, which is 0. So that's actually a horizontal line from A to C. Repeat the process going from B to D. So the slope for BD is, we'll call D second, so y2 minus y1, y2 minus y1 over x2 minus x1. That's negative 2b over 0. That's undefined, so this one is horizontal. This one is vertical. So by definition, they are perpendicular. These horizontal lines and vertical lines are always perpendicular to each other. And that's the end of this section and the chapter.